All right, radical operations. Okay, so what we're going to be doing is related back to what we've been kind of using for the last couple of weeks with the simplifying of radicals. We're going to simplify again today, but we're also going to be adding and subtracting some radical things. Okay, so we'll first review what we've done before. Simplifying something like the square root of 20. How do we do that? The tree thing, okay? So 20 could be 10 and 2, and 5 and 2, and that'd be 2 radical 5, right? Or 2 square root of 5. That's what 20 simplifies to be, okay? So that's going to be involved in what we're doing today. You're going to have to do that sum and then do either addition and subtraction after that, or maybe even multiplication, okay? So that's going to be involved with what we're doing today. This type of problem is related to what we're doing today. If I ask you to simplify that, that's the same kind of instructions that we would have had back in August when we were doing that, right? So if we're going to simplify that, what do we do? And we're not getting y by itself because we're not solving, we're simplifying. So we're going to add the what together? The like terms is the word. So we're going to put those two together. Just put your phone away. Your phone. No, it's still on your desk, huh? I'm sorry that offends you. No, ma'am, you did not. 3x plus 2x. Why do we not put 5x and 4y together? They got a different what? Different variable tied onto the end of them, okay? The difference in that and today is that we, instead of having letters there, we're going to have a radical beside that number. So today, our problems are going to look like this. 3 radical 2, maybe plus 5 radical 2. These would be like terms because they have the same radical beside them. Okay? That makes them like terms. The way we work it is just like we did this. We added 3 plus 2 together and got 5x. Here we're going to add 3 plus 5 and get 8 radical 2. You add the coefficients in front, just like we did here. The 3 and the 2 that were in front of x. X didn't change, right? Square root of 2 is not going to change here either.
What if the numbers under the radical are different?
Then you can't put them together. Okay, that's so it would either stay the same or we might have to simplify to get there. Okay, we're going to have that come up as well. So another one similar to that might be something like 5 radical 7 minus 8 radical 7. So a little subtraction problem. Are these like terms? Yeah, the radicals are the same. So we can subtract 5 minus 8, which is negative 3 radical 7. And you're done. Okay. When the radicals are the same and you're adding or subtracting, you just put the numbers in front together with whatever operation is with them. Okay. Where it gets a little tougher, but not much, is when you have something like 6 radical 5 plus 3 radical 20. They don't look like they're not the same, right? But what do we know about 20? It'll break down, right? With the factor tree. 4 times 5. 2 and 2. So there's a pair of 2's. Back when we were simplifying radicals, what happens with this 2 that we pull out and the 3 that's already out there? You multiply them back together. So we really have 6 radical 5 plus another 6 radical 5. Okay? 3 radical 20 has turned into the 6 radical 5. We simplified this radical and a 2 came out. So in between these steps, there's this 3 times 2 radical 5. That 2 is from that pair of 2's. 3 times 2 is this 6.
So what we do is multiply.
We simplify this, and then whatever you bring out is going to multiply times whatever's already there.
And then under the radical, it's going to be the same.
It's going to be whatever's left.
Oh, okay.
The 5 was left, so that's there. It won't always be the same. Sometimes you might have some like terms and some that are not. A lot of times it's going to be the same, just because that's what we're trying to learn how to do, is put the like ones together. But here, whatever's left under the radical. So 6 radical 5 plus 6 radical 5 would be 12 radical 5. But simplify down to be the same square root, so we can add them together like that. Look at another one. 3, we're going to get a little tougher. 3 radical 54 minus 10 radical 150. Are those like terms? Not currently. But do we know if 54 will break down? So let's break down 54 with the tree. We're going to do 150 as well. We're going to do it. Every radical that's in there, you've got to check to see if it will break down any. A lot of the ones here at the beginning, we didn't have to do that because they were prime numbers already underneath there. So we know that they don't break down. 9 and 6, that'd be 3 and 3. 2 and 3, there's a pair of 3's. What's left inside of the radical? 2 and 3, which is 6, right? What's on the outside of that radical now? 9, 3 times 3. The 3 that was already there times the 3 that we're pulling out. So the 3 times this 3 is 9. And then we're going to break down 150. Just the same idea. It's a tree. 150 be 10 and 15. 5 and 2. 5 and 3. There's a pair of 5's. What's that going to turn into? 6 on the inside. What's on the outside of? There's a negative 10 already. We're pulling out a what? 5. So that'd be negative 50. We pull out 1 5 for that pair of 5's. So 5 times 10 is the 50 that's there. Now, are they like terms? Yes, absolutely. Because they got the same radical. That's what makes them like terms, is that this part is the same. The 5 from the pair comes out and multiplies times the 10 that was already there.
Oh, okay.
Cadence just had a light bulb. Good. What's 9 minus 50? Negative 41 radical 6. You're done. It's really not that bad. The key that you've got to remember is for in addition or subtraction. If that's in the problem, if that's the operation that you're doing, you're going to simplify first. Okay? If it's addition, if it's only addition and or only subtraction, or just a combination of those two, you're going to simplify first. Make sure you do that, because the only way you can get like terms is simplify, like we did this last example. The only way we could get a like term was to simplify the radicals. So we've got to do those first. Okay, so addition and subtraction, simplify first. We're going to do multiplication today. Not going to do division today. We're going to do multiplication. We're about to do it right now. All right, with multiplication, if you have any kind of multiplying in a problem that you got, if there's multiplying involved, you want to simplify after multiplying. Okay, you simplify after you multiply. the way that you multiply, the rules are outside, multiply together, inside, multiply together. Okay? So if you're going to multiply two radical expressions, outside times outside, inside times inside. Outside times outside, inside times inside. Simplify after you multiply. Okay? All right, let's do some of those. Simple G. Let's just take a simple square root of 3 radical 7 times another radical expression. Let's do 10 radical 14. Okay. It's a multiplication problem, so we don't worry about simplifying yet. We multiply first. Outside times outside, it's going to be 3 times 10. Inside times inside, be 7 times 14, right? So that's what we're thinking. I'm not saying you got to write this step, but that's what's happening. 3 times 10. That's outside times outside is 30. 7 times 14, 98. Once you've multiplied, simplify. Does 98 break down? Yeah, we know it does because we got it from 7 times 14. And 14 breaks down into 7 and 2. So there's a pair of 7s. So it's going to be 30 times 7 on the outside. What's left inside of the square root? 2. What's 30 times 7? 210. Radical 2. What's 7 times 3? Add a 0. -5 radical 20 times 3 radical 8. Now, when you see a radical 20, we've done radical 20 a couple of times already in notes today. I know we've done it a few times over the last couple of weeks. Instinct says, oh, I got to simplify radical 20 because I know it will. But don't, because you're multiplying. The reason you don't want to simplify first, it doesn't make the problem wrong. It just, you're going to have to do it again at the end anyway. But why do it twice? So that's my reasoning for simplifying last. So we're going to multiply these two together. What's on the outside? -15. Inside? 160. Okay, and then factor tree on 160. 8 and 20 is where it came from. So 8 is 4 and 2. 2 and 2. 10 and 2. 5 and 2. So we got 2 pairs of 2s. So that'd be -15 times 2 times 2. What's left inside of the square root? 5 and 2. That 5 right there and that 2 right there are the ones that are not being used from the tree. So what's 15 times 4? Or here's the easier problem. What's 15 times 2? What's 30 times 2? 60. What's 5 times 2? We've simplified that radical. Do what? No, it's not hard at all. This is easy stuff.
Leave me alone.
7 radical 6. This one, for whatever reason, problems like this seem to cause issues. And I've never really figured out why, because I think they're easier. But not, I guess. All right, so multiply. 7 times 3 is 21. And 6 times 6 is 36. Does 36 break down? What's the square root of 36? So what is left? 6 times 6. So is it 21 times radical 6 or 21 times 6? Times 6. No radical anymore because the square root of 36 was 6. I don't know how many times I've counted a problem like that wrong on a quiz because people would say, oh, the square root of 36 is 6, and they'll put a radical over it. But it's gone. Once you take the square root, it's gone if it's a perfect square. So what's 21 times 6? 126. Okay. So we have multiplying when it's just multiplying, outside times outside, inside times inside, simplify. Okay? Let's combine multiplication with addition and subtraction. Three radical 15, parentheses, 2 radical 3, plus 4. What property does that look like? It is.
How do you distribute a radical?
Good question. How do you distribute? What happens when you distribute this to that one? You're multiplying, right? So we're multiplying 3 radical 15 times 2 radical 3. So that would be 6 radical what? 45. And then 3 radical 15 times 4 with no radical. So is 4 on the inside or the outside? Outside, because it's not under a radical, right? So 4 multiplies times what? 3. So that's going to be plus 12 radical 15. Now, because it's multiplied to it. 3. We're distributing this entire piece to both parts there. Shannon? Same. Okay. Now, we've done the multiplication. Now we simplify. Okay. 45 breakdown. 9 times 5. 3 and 3, pair of 3s. So 6 radical 45 is going to turn into what? Radical 5. Good job. Does 15 break down? But does it have any pairs? No. So nothing comes out. So we leave it 12 radical 15. Are these two like terms? Why not? Because the radicals are different. Okay? You won't always end up with one little bitty answer. It's like 3 radical 7. Something like that. You're going to sometimes end up with more than one piece. This is the answer. Yeah, because nothing else will simplify. We've simplified everything in the problem. All right, let's do another distributed property. Let's say we had negative 2 radical 12, parentheses, 3 radical 8 minus 4 radical 2. Okay. So it's distributed property again. What are we distributing? All this junk in front, right? So negative 2 radical 12 times 3 radical 8. 96, yeah. And then one more. Yeah, positive because it's negative times negative. Positive 8 radical 24. All right. Then we simplify the radicals. Because right now, they're not like terms. We don't know if they might not turn into like terms. We've also got to simplify them just to simplify them. 96 breaks down. We got it from 8 times 12. So I'm just going to use that. 4 and 2, 2 and 2, 2 and 6, 3 and 2. So there's one pair of 2s, 2 pairs of 2s. So what's on the outside on the front of that? Negative 24, radical what? 6. Good job. And then we break down 24. 8 and 3, 4 and 2, 2 and 2. There's a pair of 2's. Radical 6. Again, that 8 that's already out there times this pair of 2's is 16. And then this 3 and 2 are left in there. That's the 6. Are they like terms now?
Yes.
All right. So negative 24 plus 16. Negative 8, radical 6. Good job. That's right. So that one did simplify all the way down to 1. They're not always going to do that. You've got to simplify each radical just to make sure that that does not happen or does happen. Okay. There's distributive property. Pretty easy thing. The next two examples are as hard as they get today. Okay. Parentheses, radical 2 plus radical 3, close the parentheses. Another set of parentheses, radical 5 plus radical 8. Oh, me.
So you would have to distribute 2 and 5 and 8 and then 3 and 5 and 8?
Yes, each piece gets distributed separately. Absolutely. Good job. So we're going to distribute radical 2 to both of those radical 5 and radical 8. So radical 2 times 5, radical 2 times 8. So radical 2 times radical 5 would be radical 10 plus 16. Good job. And then we're going to distribute the radical 3 to each other. So that'd be radical 15, radical 24. 8 times 3 is 24. Okay. Now we go through each of those and see if we can simplify any of those. What does 10 break down to be? Any pairs? No. So that one's going to stay radical 10. So that's part of my answer. Square root of 16 is 4, so I can just write plus 4 right there. What's 15 break down to? Any pairs? No. So radical 15 is part of the answer. Well, they got an answer. Don't have a. It'd be hard to say that they're all going to be like this. Some of them will be, some of them won't be. All right. What about 24? Yeah, so 24 does break down. You know, whether you do 8 and 3 or 4 and 6 doesn't matter. It's a pair of 2's, right? So that'd be 2 radical 6. Correct? Are any of those 4 like terms? No. There's no other radical 10s. There's no other plain numbers. There's no other radical 15s. There's no others that have radical 6. So this big long thing right here, that's your answer. It really wasn't. We got one more. 3 radical 5 minus 6 radical 8. Close parentheses. Another set of parentheses. 4 radical 8 minus 5 radical 12. What we do? Okay. So 3 radical 5 times 4 radical 8 would be, okay, 3 radical 5 times 5 radical 12. Good job. Next piece. Positive or negative 24? Why? Yeah, there's a minus on that 6 radical 8. Last piece. And 72 underneath. Is that right? No, it's not 72. It's 96. Okay. Now, are any of those like terms to begin with? Radical 40, radical 60, radical 64, 96. They're all different. So I've got to break them down and see if any of them end up being that way. So 40, break 40 down. 8 and 5, 4 and 2. I made an 8. Getting close to the edge, it doesn't pick up real good with the pen. So there's a pair of 2s. So what's that gonna turn into? 2 radical 10. So it'll end up being 24 radical 10, right? And 60, break it down. 12 and 5, 6 and 2, 3 and 2. There's a pair of 2s. Good job. What's the square root of 64? What's 8 times 24? 192. 8 times 20 would be 160, right? What's 8 times 4? 32. What's 160 plus 32? It's 192. That's how I do it without the calculator. That's just breaking it apart. Yeah, it just takes more of the times you do that, the more you'll get better at it. 96, that's a different one. We got it from 8 times 12, so that's what I'm going to use to start. 4 and 3, 2 and 2. There's another 4 and 2. There's 2 and 2. 2 pairs of 2s. 120 radical 6, right? Now, do any of those go together? We got a radical 10, we got a radical 15, we got a radical 6. Then we got a regular number. None of those are like terms. Always look for those like terms on that last step. If there are some that are like terms, put them together with addition or subtraction, whatever operation is in front of them. Don't change the operation to move it over there with it. If it says minus 4 radical 3, then use minus 4 radical 3. Don't change the sign, okay? All right? Not a bad thing. It's pretty easy, actually. So